Alright, let's have a look at this question here. Well, it's asking to find the velocity and acceleration functions. Velocity is the first derivative of displacement function, so we will be able to find the velocity function there. And then I tried to do a sign diagram. I found all the zeros and the signs on graphics calculator, and then you will have the sign diagram like this. Now, don't forget, it's got a defined domain there. So when you do your sign diagram, you want to grade the part that is not in the domain. You want to show where the domain is. And then I try to find the acceleration, which is the second derivative. And then this is the acceleration function. And then I try to do the same with the acceleration function. And this is what the sign diagram looks like. And then let's have a look at what else is asked for. Well, it's asking us to find the times when the particle reverses direction. Well, it reverses direction when the velocity function changes sign. And from the sign diagram, you can see the velocity changes sign at t equals 4. So we will be able to figure out, well, the time, it should be 4 seconds later at t equals 4. And we will be able to plug the 4 back into the displacement function to find out what the displacement is at that time. And it works out it is actually negative 22, which suggests the particle is 22 meters to the left of the origin at the time of direction reverse. Now it's asking us to find the motion diagram. We need some information before we can make a start. So first we need to know what the original, so at t equals 0, what is the displacement there. We also need to know at that time what is the direction of movement at that time. Now we also need to know when the object changes direction, reverses direction, which is at 4 seconds, what is the displacement at that time. And then we also need to know what is the displacement at 5 seconds time, because that says in the first 5 seconds. And now we just need to find all this information. Okay, so this is the information we get after all the substitution. And now try plot that into the motion diagram. So this is my origin. I started off 10 meters to the right of the origin. And then my motion at that time is actually moving to the left. And I just keep going, and then I will make a turn, reverse the direction at t equals 4. And the displacement at that time is negative 22. After reversing the direction, I keep going, and the next time at t equals 5, that's where the domain stops. So I just need to count the distance in that time, and then that displacement there is 5. That's what we worked out there. And therefore, we can use this motion diagram to work out what is the distance traveled. So the distance traveled would be the first 10 meters plus 22 meters there, plus another 22 meters there, plus another 5 meters there. And that is 59 meters. Let's have a look at the next question. At what times is a particle moving at increasing speed? Now, as we mentioned in class, increasing speed is when your velocity function and your acceleration function have the same sign. So let's go back to look at what do the signs look like in those functions. So have a look. Go back. You can see they share the same sign. They got the same sign in between 1 and 3. That's when they're both negative. And also in between 4 and 5, that's where they are both positive. So the speed is increasing when t is in between 1 and 3, and also when t is in between 4 and 5. So when in between 1 and 3, that's when they're both negatives, and in between 4 and 5, that's when they're both positives. So in between 1 and 3 seconds, the object is moving towards the left quicker and quicker. And then in between 4 and 5 seconds, the object is moving to the right more and more quickly. And then it's asking at what time does the particle have its maximum speed? Now, maximum speed it is the magnitude of the velocity function we're looking at. Now have a look at this function, the velocity function. Velocity function here is a cubic function, and by looking at the sign diagram, the shape of the cubic function will be like that, where it's touching x-axis at that one, so it's negative, and then becomes a positive. So this is what the velocity function looks like. Now, the velocity function, what we know is in between 0 and 5, it's got some negative value, it's got some positive value. Now, because we're talking about the speed here, so what we're really looking at is the magnitude of this velocity. So we're actually looking at that distance. So how far away it is from the x-axis. So that's why we need to consider both the maxima and the minimum in this domain of this velocity function, because we're looking at the magnitude. So with that idea in mind, as we mentioned, the velocity function looks like that. There are some possible values where the maximum and the minimum could happen. Okay, now these are the places where where it's possible to have a minimum, and this is a place where it's possible to find a maximum, and we need to consider both situations. So let's find those information now. Because calculator is allowed, you can totally plot the velocity function and to be able to find whereabouts those are, and that's exactly what I will be doing. So at t equals 0, that velocity is -16. As you can see, it's a negative number. And a local minima happens at that point. Now, what is that point? That is a stationary point of this Vx, which means that should be the 0 in its derivative function. The derivative function of Vx, of Vt, of velocity, is acceleration. So we can totally go back and find what that point is on the acceleration function. In the acceleration function, you can see that that turning point, or that stationary point in Vt, is at 3. And if you're using your calculator, you could be finding a minimum. So V3 is a local minimum, and then we can find what V3 is. And the value found is also a -16. And then we sort of want to see when t equals 5, what is the value for the velocity. And then what you found there is the velocity is 64, which is a positive number. Now, by looking at the magnitude of these numbers, you can see this one has got the highest magnitude, 64, while these ones at t equals 0 and t equals 3, the speed is 16 meters per second. So that is to see the maximum speed is 64 meters per second at t equals 5 seconds. Now note that if this question is not asking for maximum speed, it's asking for maximum velocity, then you only need to consider the global maxima. But here, because it's considering the maximum speed, so you need to consider both the minimum and the maximum, and to compare which one has got the greatest magnitude.